Hi there. So in this video, we want to talk about a new type of mathematical construct. It's called a polynomial, and so the plural will be polynomials. All right. And in this video, we want to just talk about some basics, some basic vocabulary, etc., and then also how we add and subtract them. Okay. So the first basic term that we want to talk about is what's called a monomial. Make sure you realize the prefix on that mono. Mono means one. All right. And so what a monomial is, it's just a coefficient with a power of the variable. All right. And so typically our variable will be x, but it doesn't have to be. Okay. And so we could have something like 4x to the third. All right. Like that. And so be careful when I say a coefficient with, what do I really mean? Remember, this means times x cubed. And so if you need to, you might want to change that word with to times. Okay. Now, we might have a different variable. So we could have 8y to the fifth power, like that. Okay. And just remember some basic things. If I don't have, I might not explicitly write a coefficient, so I might write x squared or x to the second power. And just remember that actually means 1x to the second power. Okay, like that. And then also, this is getting a little ahead. I'm going to have to show you some stuff. But anytime you have just a number, so say I have 4, that is a monomial. Okay, and we'll explain this later, so don't spend too much time thinking about it now. The reason is there's a way mathematically to interpret that as being 4 times x to the 0 power. Okay, and the thing is, I won't do the explanation, but there is a basic fact is that anything raised to the 0 power is equal to 1. So this is really 4 times 1, which I could then rewrite as 4. I could replace that 1 with x to the 0. It's not terribly important for now, so if that's confusing to you, don't get hung up on it. Just realize that a number all by itself can be viewed as a monomial. Okay, and so that basic term leads into what's called a polynomial. And so you might be able to guess just from the prefix there. Poly, that means several or many. And so it's just going to be a combination of monomials. And so a polynomial is a sum of monomials. Okay. Now, one thing to be aware of, well, here, let me just show you an example first, but if you take notes, leave a little bit of space because I'm going to add something. But so I could have something like 4x to the third plus 8x to the second plus x plus 5. Okay, so there is a sum of monomials. So each one of these things right here, that's a monomial, that's a monomial, that's a monomial, and that's a monomial. Okay, now another polynomial that I could have is I could have something like 5x to the second minus 3x plus 4. Okay, like that. So now make sure, you might be saying, scratching your head though, you might be saying, hey, you told me that it's a sum, but right here I have a difference. But remember, I can always rewrite a difference as a sum. You don't need to do this. I'm just explaining why we treat subtractions as sums. Okay, like that. So if you want to, up here in that definition, it's the sum or difference of monomials. Okay, the reason we usually don't include that wording is that you can always rewrite a difference as a sum. All right, now, and then let me show you a couple more because mine are a little bit misleading. So notice in my first example, I started with the third power. I went to the second power. Remember, if there's not a power written, there's really a 1 right there. So that's the first power. And then remember, this is the 0th power with my constant. Okay, and so it seems like with polynomials, you have to have powers that they don't skip. But that's not true at all. Okay, so I could have something like x to the fourth minus 16. Okay, that goes from the fourth to the 0th power and skips all the powers in between. Okay, and then also we typically write them where the largest power is first, and then we say the powers descend because they decrease, but they don't have to. A very common thing to do is to write your constant term first. So I could have something like 4 plus 3x squared minus 5x to the fourth. Okay, and so they're written in opposite order. And sometimes just from mathematics and doing some work, they come out of completely out of order. So have something like 5x minus 4x to the third plus 2x squared plus 9 minus 3x to the eighth, something like that. Okay, so they don't have to be in order. Now, typically, especially if this is in the middle of the work, what we'll do is take an extra line and write these in order. So think about how you would do that. If I wanted to write them in order, I would write that x to the eighth term first. So I'd have minus 3x to the eighth, and then the x to the third is the next highest power, like that. And so you can rewrite things in different orders. Just make sure to keep the coefficient attached to the term, but also the sign attached to the term. All right, and so then we would have plus 2x to the second plus 5x plus 9, like that. Okay, now if you remember, the terms in any kind of algebraic expression are the things that are separated by the pluses or the minuses. So like this first example right here has 1, 2, 3, 4 terms. This second example right here has 1, 2, 3 terms. This one has 2 terms. This one has 3 terms. This one has 1, 2, 3, 4, 5 terms. Okay, now I'm going to stick to this slide, but there is some more vocabulary based on the number of terms I'll talk about in the next one. But since we have several examples here, whenever we talk about the degree of a polynomial, okay, that's the largest power, the largest exponent, okay, in a polynomial. All right, so if we go back to each one of these, if we come to this first one, the largest exponent is 3. So the degree is just a number. It's not going to be terribly important for us in this class and topic, but there are some important things later in math where keeping up with the degree is important. So if I look at this second example right here, the largest exponent is 2. So we'd say the degree of that one is equal to 2. Notice that I'm abbreviating the word degree. Okay, and then x to the fourth minus 16, the largest exponent is 4. And so we'd have the degree is equal to 4 there. And same thing with this next one. So that's important. The degree is not the first exponent, it's the largest exponent. So if we look at this example right here, the largest exponent is 4. And then either on this one we can look at this line or where we rewrote it. It's a little easier to see where we rewrote it. We wrote the largest power first. And so in this one we'd say that the degree is equal to 8. So a little more vocabulary with polynomials. So we've already mentioned this one, a monomial. That's a polynomial that only has one term in it. So then there's 2 other terms that we frequently use. A binomial, then that one would have 2 terms. Okay, we saw a binomial on the last slide. So if you remember, we had x to the fourth minus 16. So there's 2 terms. All right, and then there's another one that you can probably guess, a trinomial, and these have 3 terms. So it's a polynomial that has 3 terms, like that. Okay, and so a very common kind of trinomial to have is where the first power is the second power, or the degree is the second power. So I could have something like 3x to the second plus 5x minus 8. Okay, like that. And we don't really use special vocabulary for more terms than 3, and the reason being that these 3 are the most common types that we see and work with. You know, you could use the word quadrinomial, and I would be able to understand that you mean 4 terms, but they're just not commonly used. All right, so that's enough vocabulary to get us going. And so now what we want to start doing is doing operations on polynomials and how to do them. So we want to talk about adding or subtracting. And we basically already covered this, we just haven't practiced that a whole lot. But then the more involved part is with multiplying and dividing. Okay, and we haven't really talked about that at all. We're talking about doing this with polynomials. All right, so in this video, I'm going to talk about adding and subtracting, and then we'll break multiplying into two videos. And then we'll talk about dividing polynomials, which to do the full story, we'd need to break that into two videos. All right, and I just realized I forgot my S on that. So that's what we're going to work on. So the first part we want to talk about is adding polynomials. But what we'll see is that adding polynomials is simply collecting like terms, which we've discussed. We just haven't practiced it a whole lot with higher powers. And so remember what the idea of like terms are, is we consider things to be like terms is if they have the same variable to the same power. Okay, like that. All right, now for now, to get started, this idea of the same variable, that won't be that important. Later on, we'll look at expressions that have more than one variable, so this will be important. But the same variable, the key thing is they have the same power. So let's look at an example of what I'm talking about here. Okay, and so we'll do a few of these. All right, and so say I have, in most books they'll put these in parentheses at first, but say I have 2x to the third plus 5x squared plus 8x minus 4, and then I want to add on to that 3x to the third plus 7x minus 12. Okay, so here's the key thing about adding polynomials. If you're just adding, you can just drop the parentheses. Okay, and so you can just drop the parentheses. There's nothing to distribute or anything. And so we have 2x to the third plus 5x squared plus 8x minus 4, and then plus 3x squared plus 7x minus 12. Okay, so now we've seen examples like this, like I've said several times, and so I just realized I made a mistake there. This term right here is 3x to the third, so it comes from right there. I wrote that as the second power accidentally. Okay, so what we do is we group together parts that have the same powers. I'm going to show you another way to do this too that some people prefer. And so the idea, one thing too, I should have mentioned this before I even got started, is throughout this section, notice that this problem didn't come with an equal sign. So we are not solving equations. We are simplifying expressions. And so remember, you got to remember that. So we won't be moving things to the other side or anything like that. We're just simplifying expressions as much as we can. Okay, so I start with my highest power. You can see that my highest power is x to the third, and I have a 2x to the third there. Okay, this is the way I usually like to do it. But notice that there's another term that has x to the third in it, 3x to the third. And so I have plus 3x to the third. Okay, and then I have a plus 5x squared. Okay, and I look to see if there's any more x squared terms, but there's not, so it doesn't get combined with anything. And then I have plus 8x, and notice that there is a 7x term here, so I would say plus 7x. Okay, and then we have our constants, minus 4 and minus 12. And what that does is that groups together the like terms. Okay, now that 5x squared doesn't have one, but so I'll just group it by itself like that. So now just remember how you collect like terms. You do the operation on just the coefficients, and you keep the variable part the same. That ends up being very important, especially for later. So I do 2 plus 3 is 5, and then I keep that power, x to the third. Okay, and then I go to my next one. It doesn't have a like term, so I have plus 5x squared. Okay, and then plus 8 plus 7 is 15, and I keep my power. Okay, and then I have minus 4 minus 12, that's minus 16. Okay, and that would be the answer to that problem. Okay, so I mentioned that quickly, but make sure you realize that, especially for later, because what's going to happen whenever we're multiplying, basically on the second step, we'll end up with long expressions that look like this, and we want to collect our like terms. Make sure you realize once you're collecting like terms, you're just doing things with the coefficients. You're not changing the power on the variable at all. Whenever you're adding, or if you're collecting like terms is the other way to think about it. Now, you can see this gets a little bit confusing in here. First of all, some people, since you can just drop parentheses, some people can do this in their head. So they can go from here to here. Just be careful of that. Sometimes if you do too much in your head, it's easy to make those silly mistakes that we referred to. Okay? And so, but notice if you do write everything out, things get pretty complicated looking. And so some people like to add and subtract vertically. Okay? And do all the operations vertically. So what they'll do is they'll take that first polynomial. So we got 2x to the third plus 5x squared plus 8x minus 4. And then they'll write the second polynomial underneath it with the powers lined up. Okay, so notice on the second one I have 3x to the third. So I would put it under the 3x to the third here. Since we're going to be adding, we write that sum bar like we usually do. Now notice that the second polynomial doesn't have an x squared term. So I just leave this blank. The next term is a 7x, and so I line it up with the x. Okay, like that, and then the minus 12. Okay, so it's totally up to you how you like to do things. And, especially if things seem weird at first, then try it the other way. Okay, or you might just want to try both ways to see which way you're most comfortable with. But see, notice that I'm just adding vertically instead of horizontally. So here's another one. You might want to pause and try it. There's just a small lesson to see here. This isn't huge, but we can just drop the parentheses. Now the key thing is, be careful about that, just drop the parentheses. It's because we're adding this polynomial and this polynomial. All right, and so then we have 3x to the third minus x. Okay, now if you try to go and group your like terms together, though, here you have an x to the fourth, but there's no more x to the fourth terms. And then we have a plus 3x to the third, but there's no other x to the third terms. And then the next highest power is x, so we have minus x, but there's no other x terms. And then I have minus 16, but no other constant terms. Okay, so that ends up being the answer. And all I'm trying to point out is expressions don't always have like terms. Okay, they often do, but they don't have to, so be careful of that. Now I want to show you how to do this vertically too, if you prefer to do that. So here we have, on my first polynomial, I have x to the fourth minus 16. But since I'm going to line things up, if you're missing powers, you want to leave spaces. So this would be the x to the third, this would be the x to the second, this would be the x, and here would be your constant term out here. So you might want to write that minus 16 out there. Okay, and then for your second polynomial, it starts with the third power, so it would be 3x to the third. Okay, and then it's missing a second power, and then it has a minus x, like that. Now, there's one place you might get confused if you do this vertically. So it's pretty obvious the first term is x to the third. So you might, since I didn't write a plus in front of that 3x cubed, you might write it this way, like that. But you need an operation in between them, so you got to remember that there's really a plus right there. So you got to remember to put that plus in there. Okay, and then minus x minus 16. Same answer that we got before. Okay, let's look at another one. Say I have 7x squared plus 5x minus 6 plus 2x to the second minus 5x plus 10. Okay, like that. So if you want to do it horizontally, you realize that you can drop the parentheses, and so you have 7x squared plus 5x minus 6 plus 2x squared minus 5x plus 10. Okay, like that. The way I do this is I group together my like terms. So there's a 7x squared and there's a 2x squared. There's a plus 5x and a minus 5x. And then there's a minus 6 and a plus 10. Okay, and so these all have like terms. Okay, like that. And so remember, if you're collecting like terms, the variable part stays the same, and all you do is add or subtract the coefficients. So 7 plus 2 is 9. Okay, now this is the reason I did this example here. We have 5x minus 5x. That's 0. Or if you think about doing what I said before, the variables part stays the same, and then I just do the coefficients. 5 minus 5 is 0, okay? And it just depends on how much you see and how much detail you like to have from step to step. The key thing is to remember that 0 times anything is 0, and then if you add 0 to something, it doesn't change anything. And so the key thing is we get 9x squared plus 4. And like I say, I don't insist that you do each one of these steps. It's more up to you. I do like to go step by step. I've done so many of these in my life that I've reached the point now where I can go from here to here. But whenever I was learning, I would be very careful with my steps. The reason for that is, A, it doesn't overload my brain and I make less silly errors. And then B, if I do make an error, it's easier for me to trace back through the problem and find where that occurred at. Okay, now if you want to do this vertically, here, let me separate it out over here. Okay, you would have 7x to the second plus 5x minus 6. All right, and then notice all of these line up perfectly. That, and then you just have 7 plus 2 is 9x squared. Hopefully you realize that that's 0, and then we have plus 4. Okay, and so that'd be 9x squared plus 4. Same thing that we got. So that is our answer to that one. All right, now don't let this example scare you. It's just fractions, okay? And we do everything exactly the same. It just might require a little bit more work. But you can think that since we're adding here, we can just drop the parentheses. So I'm going to skip one step here to save some time. And so I'm just going to group together my like terms. And so notice that I have a 3/4 x to the third, and then I have a plus 5/6 x to the third. Okay. Now this one doesn't have an x squared term in it, but this one does. So I'd want to write it next. And so I have plus 3/7 x squared. And then I have a plus x on my left term, but there's no x over here on my right term. And then we have minus 1/2 and plus 5 for my constants. Okay? Now, the key thing is here, I do have these like terms with fractions in them. All right? And so I'm just going to have to do that. You could, there's different ways to think about how to write this. But the key thing is, since you're just collecting like terms, that's going to stay as x to the third. And then I'm going to have 3/4 plus 5/6. Okay? So remember, we just add or subtract our coefficients. So that I just put that in parentheses to show myself what I'm doing there. Okay? But that x squared term doesn't have any like term, another like term with it, so it's just there. Same thing with the x term. Okay? But here I do have minus 1/2 plus 5. Be aware with polynomials, because we often substitute values in for the variable and have to calculate. You don't want to use mixed fractions with these calculations. So I got to do minus 1/2 plus 5. Make sure you realize that's 5 over 1. And so my common denominator is going to be 2. So I have minus 1/2 plus 10 over 2. Okay, you might need to pause it and go back over that. I know I'm being quick with it. Okay, same thing here. We need a common denominator here. If you get the basic common denominator by multiplying them, it's 24. But the LCD right here, if you think about it, is actually 12. So whichever one you want to use. I'm going to use the 12. With that. And the key thing is, remember how to convert. I need to figure out what I multiply this by to get the new denominator. 4 times 3 is equal to 12. So I also multiply this 3 by 3, and I get 9. Okay, and then here on my second part, I started with a 6, but I want to get 12, so I have to multiply by 2. So I also do the same thing in the numerator. So 5 times 2 is 10. Okay, remember my advice before too. Whenever you're working on part of an expression, but not all of it, then just rewrite the parts that you haven't worked on. If you leave them behind and you just start working on that first part and keep going down with this, it's easy to forget that these other parts are still in the answer to your problem. All right? And so anyway, now that I have a common denominator, I just add in the numerator. So I get 19/12 x to the third, and then plus 3/7 x squared, plus x. And then here I have a common denominator 2, so I just do negative 1 plus 10. That's 9, so I get plus 9 halves. And then that would be my answer. Okay? I'm not going to go through the whole thing since I've been through the arithmetic part, but if you're going to do this vertically, just remember to leave space for missing power. So in that first one, I have 3/4 x to the third, but it doesn't have a squared power, so I'd leave a blank, and then I'd say plus x minus 1/2. So then whenever I go to write that second one, I have 5/6 x to the third. I've left myself some space for that x squared term to fit in there. Okay, and then that one's missing an x term, so then I'd leave a blank and write plus 5. And that just helps you keep things lined up about what you need to add together and what can just drop down. Likewise, with polynomials, don't let yourself get confused if problems show up with decimals in them. All right, you do everything just the same. Since I'm adding, I can drop the parentheses and I can group together my like terms. And so my first polynomial starts with an x squared, and notice that there's a 0.5x squared in the second one. All right, and then we have a 0.3x in the first one, and a minus 0.7x in the second one. And then we have a minus 0.15 in the first polynomial and a plus 1. Okay? So remember the idea here. You don't necessarily need this step, but remember the idea of collecting like terms is that you keep your power of your variable, and then you just do the operation on the coefficients like that. And now the reason I'm pointing this out, some of you can do this in your head, or write it out over on the side as scratch work, or feel free to use your calculator there too. It doesn't matter to me. All right, and so we get 0.62x squared, okay, like that. And then we have this one right here is 0.3 minus 0.7x. Okay, so on our calculators, if you want to use your calculator, you do 0.3 minus 0.7, and that's going to give you minus 0.4x, like that. And then same thing here, you have minus 0.15 plus 1. That's going to give you plus 0.85. All right, and so that ends up being the answer to that. And you can just as easily do this one vertically. I'm just seeing that this video is starting to get long, and so you just line things up with power. Okay, now with subtracting ends up being a lot like adding, except you're going to be subtracting something, so you're going to have a minus sign in there. So the way to abbreviate this is you distribute the minus and add, or maybe a better way to even say that is then collect like terms. Okay, and we've discussed this. It's just been a while since we've used it about how to distribute that minus. All right, and so let me just show you an example here. And so I might have something like 7x squared minus 2x plus 4, and then minus 3x squared minus 5x plus 1. Okay, so here's what I'm talking about here. Here's my minus sign. Now I'm going to show you the long way to do this, but you'll see this ends up getting a little bit cluttered. Okay, so remember we can always rewrite that minus as a plus negative 1. So I can think about this as being 7x squared minus 2x plus 4 plus negative 1 times this parenthesis. Okay, like that. I don't advise doing problems this way. I used to teach it this way, I'll be honest with you, but people got really confused with all the pluses and minuses that show up in here. Okay, but let me go ahead and show you that real quick. So A, you can see that how it gets confusing, but B, we'll also see a shortcut that'll make it a lot easier. Okay, and so here we have 7x squared minus 2x plus 4. Now notice I have this plus here, so I'm going to leave that plus, okay, and I'm putting that negative 1 into the parentheses. So I have negative 1 times 3, that's negative 3x squared. And then here I have minus, and then I have negative 1, or negative 1 times 5, that would be negative 5x, like that. and then I have plus, and I have -1 times +1, which is -1. And so then notice here that we have this minus and a minus and a plus and a minus. Okay, and so we have 7x squared minus 2x plus 4, and then plus -3x squared plus 5x minus 1. Okay, now here's the key thing. So you can see it gets cluttered, and it's easy to misdistribute that -1 and so on because of all those signs. But look what happened here. Here I started with positive 3x squared minus 5x plus 1 before I distributed that minus. So I have plus 3 minus 5 plus 1, right? What did I end up with? A minus 3, a plus 5, and a minus 1. Just the opposite of what I started with in terms of signs. Okay? So what I'm trying to get at here is whenever I talk about distributing that negative, if all you're doing is distributing a negative, okay, there's no other number attached with it, all that does is just change the signs, okay? So distributing the negative just changes the signs. So you can shortcut that process by realizing that, okay? So the better way to do this problem here is you have 7x squared minus 2x plus 4. I'm just rewriting the problem now. So what you can do is you can change that minus to a plus in the middle, like that, and then just change all the signs inside. So I had positive 3, so that's going to become minus 3x squared. Then I have minus 5x, so that's going to become plus 5x. And then I have plus 1, so it's going to become minus 1. Okay? And the key thing is here, now we're just adding, and so it becomes just like the last problem, or the last set of problems with adding. Okay? I would take, my first one starts with 7x squared, but notice this other one has a minus 3x squared. And then here I have a minus 2x, and I have a plus 5x, and then I have a plus 4, and I have a minus 1. Okay, like that. And so now I have these three sets of like terms to collect together. So I have 4x squared, or 4x to the second. Be careful here, I have minus 2 and plus 5, so that gives me plus 3x. And then I have 4 minus 1, which is 3. And you can do these vertically. What I would advise doing first before you do it vertically, though, is to do this step right here. Change the minus to a plus, and change all the signs on the second one. So then, whenever you went to set up your vertical format, you're just adding, so you don't have to worry about. Some people will do this as a subtraction, but it's very easy to make mistakes if you do it that way. Okay, so I would take care of that minus or that subtraction first, and then set things up vertically. All right, I started to give you some to try, and I realized there's something I forgot to mention earlier in the video. So, but let's not worry about that right now. Let's just treat this as a problem. Okay, so notice here the difference with this problem is I'm subtracting. So the first thing I want to do is just rewrite the problem as an addition. Okay, and so I don't mess with the first polynomial at first. So what I do is I change that minus to a plus. Okay, like that. Okay, and then I go and I change all the signs on the inside. So I have minus x cubed plus 3x squared minus 2x and minus 8. Okay, so now this is just an addition problem. So once I'm just adding, then I can group together my like terms. And so I have x to the third minus x to the third. And then I have plus x squared. And over on the right, I have plus 3x squared. Okay, this first polynomial doesn't have an x term in it, but the second one does. And so I'd write minus 2x, and then I have minus 8 and minus 8. Okay, like that. Now, here's what I want to talk about this second part here, because this is the part I forgot to mention. So, and then we'll mention the first part in a second. Okay, so how do you collect these? Those are both x squared terms, so the x squared is going to stay, And here I have a plus 3, but what does the plus 3 get added to here? So remember, if a coefficient's not written, we can include a 1 in front of it. Sorry that I forgot to mention that earlier. Okay, so I do 1 plus 3, so this is plus 4x squared. Okay, now here, remembering that, these both have 1's in front of them. I do 1 minus 1, that's 0x to the third. Okay, like that. And then the 2x, the minus 2x doesn't have any like terms, so I have that. And then here you got to be careful. I have negative 8 minus 8, so that's actually minus 16. Okay, now just remember, anytime your coefficient is 0, that whole thing is 0. So that drops out, and so it's tempting to write your answer as plus 4x squared, not cubed, 4x squared minus 2x minus 16. But as we've seen a lot of times, if an expression just starts with a plus, we don't write it. So typically the way we would write the answer is like this. Okay? Okay, so here's probably 2 problems to practice. I would advise pausing it and see if you can get them, so that whenever I do them, hopefully you got them right, but if you didn't, you can see where you made mistakes and know where to be more careful once you get to homework. All right, so hopefully you pause. This is your last chance, so I'm about to start. Okay, so I've done this slightly different in the past, and I haven't exactly explained it the way I just did in the video. It kind of came to me as I was writing it. All right, so I would highly advise following that scheme. Just at first, leave the first one the same, and then change your minus to a plus, and then change all the signs on the inside of your second polynomial. I think you'll be a lot more successful doing it that way, because then now you just have an addition problem, and so you can put the extra line in where you just drop the parentheses, or you can just start grouping together like terms now. So this first one starts with 5x cubed, and then I have a minus x cubed in the second one, and then I have a minus 4x squared in my first one, and I have a plus 4x squared in my second one, and then I have a minus 8x in my first one, and I have a plus 3x in my second one, and then I have a plus 4 in my first one, and a plus 2 in my second one. So everything has a like term here. Okay, like that. So there's my 4 sets of like terms. And so just remember, and you can write it if you need to, so just remember that coefficient right there is 1, so I do 5 minus 1, which is 4x to the third. Okay, and then here is one of these. I have minus 4 plus 4, so that's just going to be 0, so it'll drop out of my answer. All right, and then I have minus 8x plus 3x. That's, we need negative 8 plus 3, which is minus 5, but I keep my variable part. And then I have 4 plus 2 is plus 6. All right, if you write that 0 there, we typically don't write it in the answer. And so we get 4x cubed minus 5x plus 6 is our answer. Okay, now for the second one, part of this is I realized too that I've only used x, so don't worry if you have a different named variable. Okay, everything works the same. All right, so I change my minus to a plus, and then I change all my signs on the inside. 2y squared, oops, I almost messed up. I got to change all my signs. Minus 7y and plus 5. Okay, so now I just need to collect regroup. Now I'm just adding, right? And so I just collect group like terms. So this first one starts with 14y to the 4th power, but there's no other 4th powers. There's no third powers in this also. So then the next set of terms would be plus 8y squared and plus 2y squared. Okay, and then there is just a y to the 1st power, minus 7y, and then I have a minus 3 and a plus 5. Okay, like that. And so notice that there's several here that don't have like terms. So if they don't have like terms, you just rewrite them. Okay, and so here I do 8 plus 2, that's plus 10, but we keep our power, our variable in our power, like that. And then that minus 7y doesn't have a like term. And then I do minus 3 plus 5, which is plus 2. That would be the answer. Okay, so that's all we're going to do here, but a couple important things. Remember that once you're adding, all you're doing is collecting like terms. But the important thing about collecting like terms is, notice whenever you're collecting like terms, you just operate on the coefficients, but the variable and the power stay the same. Okay? And then the other thing is, to do a subtraction, all you have to do is change the minus to a plus, keep your parentheses at first, but then change all the signs on the inside of the second parenthesis. And to me, that seems a lot cleaner way to avoid silly sign errors that's easy to make. Okay, I hope that helps. All the best.